Hey guys, welcome to Master and Learn It. In this video, we are going to be learning about factors, prime numbers, highest common factor, and lowest common multiple. If you haven't subscribed to my channel, please do so by clicking the subscription button to Master and Learn It so that you'll be notified each time we release a new video. Let's start by defining what is a factor. A factor is a whole number that divides exactly into another number. So that means that number should not leave a remainder. For example, factors of 6 are 1, 2, 3, and 6. Because 1 can divide 6, because 1 can divide into any number. 2 can divide into 6, because 2, 4, 6. That's 3 times. 3 can get into 6. 3, 6, 2 times, and 6 can get into 6, 1 time. So these are the factors of 6. You would realize that 4 is not a factor of 6 because 4 is a whole number but cannot divide into 6 without leaving a remainder. For example, we can have factors of 8 would be 1 always is a factor. 2 can divide into 8 4 times. 3 cannot divide into 8, is not a factor. 4 can divide into 8, is a factor, as well as 8. Let us move on to understanding what is a prime number. By definition, a prime number is also a whole number that has only 2 factors. It only has 2 factors, which are 1 in itself. Let us have a few examples of prime numbers. I'm going to write numbers here on the board. Writing 1, the factors of 1 are 1 only. Factors of 2, it's 1 and 2. Factors of 3, it's 1 and 3. Factors of 4, it's 1, 2, and 4. Factors of 5 is 1 and 5. Factors of 6 is 1 and 6. Sorry, factors of 6 is 1, 2, 3, and 6. Factors of 7 is 1 and 7. Factors of 8 is 1, 2, 4, and 8. Factors of 9 is 1, 3, and 9. Factors of 10 is 1, 2, 5, and 10. The list keeps going on and on. So from these few numbers that we have, we want to check which one is a prime number. 1 is not a prime number because it only has 1 factor. 2 is a prime number because it only has 2 factors. 3 is a prime number, has 2 factors. 4 is not a prime number, we will learn that in the next video, is a composite number because it has more than 2 factors. 4 is not a prime number. 5 has only 2 factors, it's a prime number. 6 has more than 2 factors, is not a prime number. 7 has 2 factors, is a prime number. 8 has more than 2 factors, is not a prime number. 9 has more than 2 factors, is not a prime number. 10 has more than 2 factors, it's not a prime number. So I'm going to list the few prime numbers that we should memorize. Let me be basic. So the first few prime numbers we should memorize: 2 is the smallest prime number, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. As the list goes on and on and on. We should know that we can write any number as a product of its prime factors. For example, I can write 8 as a product of its prime factors. What does that mean? I'm going to write 8 in terms of prime numbers. For me to get 8, I would say it's the same as the first prime number is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. But someone might ask, how did I know that 8 is prime factors is 2 times 2 times 2? The answer to that is what we call the ladder method. For me to write 8 as a product of its prime factors, I use the ladder method. I'm going to divide 8 by the smallest prime number, which is 2. How many times does 2 get into 8? 2, 4, 6, 8. 4 times. I'm going to divide 4 by the smallest prime number, which is 2. 2 into 4, we know that's 2. I'm going to divide this 2 by the smallest prime number, 2, which is 2 into 2, that's 1. So 8 as a product of its prime factors is 2 times 2 times 2. 2 times 2 times 2. We can do that for any number, and I mean any number. For example, if I say write 20 as a product of its prime factors, you would still divide by the smallest prime number, which is 2. 2 into 20, that's 10. Which number, smallest prime number that can divide 10 is still 2. 2 into 10, that's 5. If you don't know, you just count in 2s until you get 10. 2, 4, 6, 8, 10. So you have 5 figures, which is this 5. 2 cannot divide into 5 without leaving a remainder. In other words, it's not a factor of 5. 3 is not a factor of 5. But 5 is a factor of 5. So 5 divided by 5 is 1. So I can write 20 as a product of its prime factors as 2 times 2 times 5. Notice that these are all prime numbers. And they can give us 20 because 2 times 2 is 4. 4 times 5, that's 20. What do we use? What is the use of writing a number as a prime factor? Prime factorization enables us to calculate the highest common factor and the lowest common multiple. So we are going to use the ladder method to write a number as a product of its prime factors to get the highest common factor and the lowest common multiple. Suppose we say what is the highest common factor of 20 and 16. We are looking for a number, actually a factor. Remember, we've defined a factor as a number that divides exactly to another number without leaving a remainder. So I'm looking for the factor that divides 20 and 16 without leaving a remainder. It can be difficult for me to do it by hand. But if I'm to use prime factorization, I'm going to write 20 as a product of its prime factors, as well as I'm going to write 16 as a product of its prime factors. Writing 20 as a product of its prime factors, divide by the smallest prime number, that's 2. 2 into 20, that's 10. If you have a challenge, just divide 1 by 1. 2 into 2, that's 1. 2 into 0, that's 0. So that's 10. The smallest prime number that can divide 10 is still 2. So 2 into 10, that's 5. The smallest prime number that can divide 5, it cannot be 2. 2 is not a factor. 3 is not a factor, so we divide by 5. 5 into 5, that's 1. So writing 20 as a product of its prime factors would be 20 is equals to 2 times 2 times 5. Writing 16 as a product of its prime factors, we divide by the smallest prime number, which is 2. 2 into 16, that's 8. We can count using your fingers. 2, 4, 6, 8, 10, 12, 14, 16. So we have 8. The smallest prime number that can divide 8 is still 2. 2 into 8, that's 4. The smallest prime number to divide 4 is 2. 2 into 2 is 2 into 4, that's 2. The smallest prime number to divide this 2 is still 2. 2 into 2, that's 1. So 16 can be written as 2 times 2 times 2 times 2. So writing 16 as a product of its prime factors is 2 times 2 times 2 times 2. 2 times 2 times 2 times 2. Which is this. Then please be careful that on a highest common factor, we only take the things that are common only. This is an important point. On a highest common factor, we need the things that are common, or the factors that are common. In this case, 2 is common, times 2 is common. What else is common? There is 5, there is no 5 here. There is 2 down here, there is no 2. There is 2 down here, there is no. So these were the only 2 numbers that were common. So when I multiply them, I get the 2 times 2, that being 4. I'm going to write that aside. So the highest common factor of 20 and 16 would be 4. Now let us do one last example before we move on to the next part. Finding the highest common factor of 60 and 32. I'm going to divide 60 by its prime factors, divided by the smallest prime factor, which is 2. 2 into 60, that's 30. The smallest prime factor that can divide 30 is 2. 2 into 30, that's 15. The smallest prime number to divide 15 is 3. 3 into 15, that's 5. The smallest prime number to divide 5 would be 5. 5 into 5, that's 1. Writing 32 can be written as the smallest prime number would be 2. 2 into 3, that's 1. Remainder 1 into 12, that's 6. The smallest prime number to divide 16 is still 2. 2 into 16, that's 8. Smallest prime number to divide 8 is still 2. 2 into 8, that's 4. The smallest prime number to divide 4 is still 2. 2 into 4, that's 2. The smallest prime number to divide this 2 is 2. 2 divided by 2, which is 1. So writing these numbers, I have 60. 60 can be written as 2 times 2 times 3 times 5. 2 times 3 times 2 times 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. Which is 2 times 2 is 4 times 3, that's 12 times 5, that's 60. Writing 32 is 2 times 2 times 2 times 2 times 2, which are 5 2's. 2 times 2 times 2 times 2. Now, on a highest common factor, we say we only take things that are common. So the factors that are common, 2 is common, times 2 is common. What else is common? There is nothing that is common. So 2 times 2 we get 4. So the highest common factor of 60 and 32 would still be 4. Now let us move on to what is called the lowest common multiple. On the lowest common multiple, the only difference is we take the things that are common as well as the things that are not common. For example, if I'm to say what is the lowest common multiple of 2 and 3? Writing 2, we know 2 is just a prime number, so writing 2 as a product of its prime factors is 2 times 1. Writing 3, we know 3 is a prime number. Writing 3 as a product of its prime factors is 3 times 1. Remember, on the lowest common multiple, we take what is common plus the remaining. Here, there's 1, I take 1 times, what else is common? Nothing, I've taken what is common, and I have to take what is remaining. 2 is remaining, I have to take it. 3 is remaining, I have to take it. So 1 times 2 is 2, times 3 is 6. So the lowest common multiple of 2 and 3 would be 6. Let us try a little bit bigger number. What is the lowest common multiple of 12 and 20? Remember, on the lowest common multiple, we're still going to use our prime factorization to write 12 as a product of its prime factors as well as 20. Writing 12 as a product of its prime factors, I divide by the smallest prime number 2. 2 into 12, that's 6. Smallest prime number that divides 6 is still 2. 2 into 6, that's 3. The smallest prime number that can divide 3 is 3. 3 into 3, that's 1. Writing 20 as a product of its prime factors, I divide by the smallest prime number 2. 2 into 20, that's 10. Smallest prime number to divide 10 is still 2. 2 into 10, that's 5. Smallest prime number to divide 5 would be 5. 5 into 5, that's 1. So writing 12 as a product of its prime factors is 2 times 2 times 3. Writing 20 as a product of its prime factors was 2 times 2 times 5. Remember, on the lowest common multiple, we take what is common as well as what's remaining. So I'm going to start with what is common. 2 is common, times 2 is common. What's remaining? 3 is remaining, I take it. 5 is remaining, I take it. Now our lowest common multiple of 12 and 20 would be 2 times 2, that's 4. 4 times 3, that's 12. 12 times 5, that's 60. So this would be our lowest common multiple. I hope this video was so helpful to you. If you have any questions, you can just write a comment so that I know what to improve on this video. Thank you so much.